Hey, what's up everyone? In this video, we're going to be learning about recursion using Java. Recursion is not a keyword or framework or anything to do with the syntax, but instead it's a programming technique in where a method calls itself. The idea is that every time the method calls itself, the problem being solved gets smaller and smaller until it reaches a stop. But what exactly does this all mean? Let's start off with a poem that helps visualize this concept. A child couldn't sleep, so her mother told a story about a little dog who couldn't sleep. So the little dog's mother told a story about a little cat who couldn't sleep. So the little cat's mother told a story about a little mouse who fell asleep. And the little cat fell asleep, and the little dog fell asleep, and the child fell asleep. As you can see with recursion, we start going down this hole. Notice how each animal tells a story about another story, about another story, and so on. This is called the recursive case. Also notice how the animals get smaller and smaller. This is called the change. When recursion is done properly, there's eventually a stop somewhere down the line. This is called the base case. When recursion is not done properly, it just keeps going on and on and on until the computer runs out of memory and the program stops. Let's take a look at a few examples. We'll start off with some simple examples and work our way to more complex ones. All right, so in this example, we're going to take a look at a recursive method that calls itself over and over and over again. So here I have a class called demo, and it's just got two methods. It's got main, and it has this other method here called infinite. Now what this infinite method does is it simply prints the text hello, and then it calls the infinite method. In other words, it's calling itself, right? Now, don't think that the computer is just going back to the beginning here and then runs the statement, and then once it sees this, it goes back to the beginning. It doesn't really work like a loop. Think of it more like this. If I were to copy this right here, right? The logic for this infinite method. Every time we see a call to the infinite method, just pretend you're pasting the logic right underneath it, okay? So you'll see here that there's yet another call to the infinite method. So we can paste the logic right underneath it. And you'll see that here there's yet another call to the infinite method. So we can paste the logic yet again. And it just keeps going on and on and on, right? And it's like you're going down this rabbit hole. You'll see that everything is just sort of nested. So think of it more like that instead of a loop. So let me go ahead and just delete all of this right here. Okay. All right. So here I am calling infinite from the main method. So we can go ahead and run it and just see what happens. So I'm going to go ahead and click on run. And you'll see that we get all these errors here. Now, if I scroll up, you'll see that it did print hello quite a few times actually. And if we scroll down, here it says exception in thread main stack overflow error. So this pretty much just means that the computer ran out of memory, right? It was running this method over and over and over and over again, but it was just doing it so many times that it eventually ran out of memory. And this is a really big issue when using recursion. So you have to be very careful so that your recursive method doesn't call itself an infinite amount of times, because then you're going to run into this error here. So obviously this is an example of something that you do not want to do. So what you need is you need something to stop these recursive calls somewhere down the line. And this stop is called a base case. And that's what we're going to look at in the next example. All right, so in this example, we're going to take a look at a recursive method that calls itself a finite number of times. So here, I just have a class called demo, and it has two methods. Here we have our main method, and here we have another method called finite. Now you might have also noticed this global field up here called count, and it's assigned the value of 0. Now this count is really important because we use it down here inside of the finite method. You'll see that once we go inside the finite method, it does count plus plus. Now what plus plus does is it just increments the value of that variable by 1. So you see how count started off at 0? When it does count plus plus, count will now be 1. Okay. Now this right here is called the change. If there is no change, things are just going to stay the same. So this count is really important because in the next line, we have a check. We see here it says if count is less than or equal to 5, which remember at this point count is 1. So if 1 is less than or equal to 5, then do this. If this turns out to be false, then it's just going to exit the method and the application is just going to continue. Okay, so that's actually what we want. We don't want the recursive method to just go on and on and on, just like in the previous example. We want it to have an end somewhere down the line. And this right here is what sort of controls that, okay? So as you can see, once count reaches 5, that's going to be the last case in where this is going to run. And that is called the base case, okay? So here, what it's going to do is it's going to print the text hello, and then it's going to print the value of count. On the next line, it's going to call the finite method. In other words, it's going to call itself, right? Now, when I say it calls itself, don't think of it like it's going back to the beginning and then it's just running through all these statements. Don't think of it like a loop. Instead, think of it as if you were copying the logic for the finite method, and every time you see the finite method being called, just go ahead and paste that logic right underneath. So it's like it's starting a new finite session, okay? So here it's calling finite, and you'll see that in the next line, it's doing count plus plus. Now remember, at this point, with this first count plus plus, count went from 0 to 1. Once it goes down here and it does count plus plus again, count will then be 2. So then it goes into the check, and this says if 2 is less than or equal to 5, then do this. Now 2 is less than or equal to 5, so it goes ahead and prints hello, and then it prints the value of count. Okay, so at this point it's going to print hello, and then 1, and then down here it's going to print hello, and then 2. And again here, when it calls the finite method, just pretend you're pasting the logic right underneath that again. Okay, so now it does count plus plus again, so now count is 3. So in the next line, it's going to check if 3 is less than or equal to 5, then do this. Of course, that is true, so it is going to print hello, and it's going to print the value of count, which, again, at this point is 3. So we're going to see hello 1, hello 2, hello 3, and then here we see another finite method, so you can go ahead and paste the logic yet again, and so on. So as you can see, it's like we're going down this rabbit hole, right? However, you'll notice that if we continue, count will eventually get to 6, right? So if we read this again, while count is 6, it's going to read like this. If 6 is less than or equal to 5, then do this. Of course, that is not true. 6 is not less than or equal to 5, so it's not going to run this, but instead it's going to exit the method. Okay? So let's see this in action. Let me just go ahead and delete all of this. So let's go ahead and see this in action. And I'm going to call the finite method from my main method. So let's go ahead and click run. And you'll see here in the output, it prints hello 1, hello 2, hello 3, hello 4, hello 5. Okay. So this is an example of a recursive method that has all the things that are necessary for a well-written recursive method. So here we have, of course, the change. If you don't have a change, nothing's going to change, right? And here we have the recursive case, which is where the method calls itself. All right, so hopefully things are making a little bit more sense. Stay tuned for the next example where we're going to go over a recursive method that adds numbers. All right, in this example, we're going to take a look at a recursive method that adds up all the numbers for the given input. So for example, if we were to provide the number 3, right? What this method is going to do is it's going to add 0 plus 1 plus 2 plus 3. And if you do the math, that'll give you 6, right? Just like in the previous examples, here I have a class called demo, and inside I have two methods. We have our main method, and here we have our new method called sum. And unlike the previous examples, this method takes in input. Okay, more specifically, it takes in an integer. All right, so let's go through the flow. Let's say that we provide 3 as the input. So if k is 3, we go to the next line, and here it checks if k is greater than 0, run this. Otherwise, run this. So at this check, it's going to say if 3 is greater than 0, which it is, right? 3 is greater than 0. So it's going to run this. So this right here is made up of two parts. The part on the left is pretty easy. We know that k is 3, right? And the part here on the right, well, this, we're not too sure what this is, right? We know we're adding 3 plus something, but what is this something? Well, it's important to remember that when you call a method, it must always return some kind of data, unless the return type is void. But we see here that this sum method has a return type of int. So every time we call sum, we are expecting it to return an integer. Okay, so now things are starting to make a little bit more sense. Here we're doing 3 plus whatever this returns. Now to know what this is going to return, we need to go down the rabbit hole. So what I'm going to do is I'm going to copy the logic for the sum method, and I'm going to paste it right underneath this sum call right here. Okay. So again, k is 3, and we're trying to add it to whatever this is going to return. Notice how this sum call is going to have a new input. So if k is 3, we're going to subtract 1 from it, so 3 minus 1 is 2. So now here k is 2, and it's going to check. If 2 is greater than 0, which it is, right, then do this. So here, k is going to be 2, and it's going to add that to whatever this returns. So as you can see, we're going down this rabbit hole even deeper. So let's go ahead and paste the sum logic right underneath this new sum call. So again, k is 2 at this point, and this new input for this new sum logic is going to be 2 minus 1, which is 1. So at this point, k is 1, and it's going to check if 1 is greater than 0, which it is, do this. So k at this point is 1, and it's going to add that 1 to whatever this is going to return. So we go yet another level down, okay? So I paste this here. So again, k at this point is 1. So here for this new input, it's going to be 1 minus 1, which is 0. So k here is going to be 0, and it's going to check. If 0 is greater than 0, do this. Now, 0 is not greater than 0. So it's not going to run this, but instead, it's going to go to the else block. Okay? And this right here is where the recursive calls end. Okay? This is our base case. And in case you haven't already noticed, on this line here, we have both our recursive case, okay, you'll see. So remember, the recursive case is just where the method calls itself, okay? And we also see the change. We see that every time the method calls itself, there's a change in the input. It's doing k minus 1, right? So we have all the parts that make up a recursive method, okay? Anyway, going back to this, we see that we finally reached the bottom, and here it returns 0. So this value of 0, this is being returned for which sum call exactly? Well, it's this one right here. So this specific sum call is returning 0, okay? If we move backwards, and here I'm just going to delete some of this so that it's easier to visualize, okay? Here we want to know what this returns. Well, we know that at this point, k was 1 down here, right? So what this is going to return is 1. All right? Here I'm just deleting some extra code that we don't need. Again, this is just to better visualize. We're not actually going to run it with all these different levels. Okay, this is just to better visualize everything. So the question is, what is this going to return? This is going to return this, which is 2, right? Here I'm going to do the same thing. The question is, what is this going to return? And this is going to return 3. Okay? So as you can see here, this call, okay, this right here returns 0, this one here returns 1, this one here returns 2, and this one here returns 3. So if they're all added together, it would be 3 plus 2 plus 1 plus 0. But because we're sort of working our way back up, right? So because it's bubbling back up, it makes it seem like it's really doing 0 plus 1 plus 2 plus 3, okay? And either way, you're going to get the same result if you do, if you do it from left to right or right to left. Now, of course, that's not the case with division or subtraction, but in this particular case with addition, it does work, okay? So anyway, when you add 0 plus 1 plus 2 plus 3, that is 6. right? So I'm just going to delete all of this extra stuff that I pasted, and here we are back to normal, okay? Now inside of the main method here, I'm simply calling sum, providing the input of 3, and I've surrounded all of it with a system.out.println so that we can see the answer here on the console window, okay? So I'll go ahead and click run, and you'll see that the result is 6. So hopefully things make a little bit more sense now. Stay tuned for the next example. We're going to take a look at a very similar recursive method, except only this time it's going to multiply the numbers together. All right, so in this example, we're going to take a look at a recursive method that is very similar to the one in the previous example, except instead of adding the numbers, it's going to multiply them. So if we were to provide the number 4 as the input, it'll do 1 times 2 times 3 times 4, okay? And that's what factorial means, okay? All right, so here I have a class called demo. There are just two methods inside. We have our main method, and we have this method here called factorial, okay? So we know that this factorial method takes in an int and it returns an int, okay? Now, one thing you'll notice is that it's very similar to the previous example, except that we now have our base case up here in the if block, and we have our recursive case and change down here in the else block. So these two have pretty much been swapped, okay? And the reason I wrote it like this is just to show everyone that you can design your recursive method in many different ways. You could still get the same result, just design it or code it in different ways, okay? If we start off with the number 4 as the input, right? N at this point is 4, so it's going to check. If 4 is equal to 1, then it returns 1. Of course, 4 is not equal to 1, right? So it's going to go ahead and just run this right here. All right, so a lot of you might already have a good idea on how to solve this, especially if you followed my previous example. I'm going to show you a different way of doing it. It's not necessarily easier or harder, it's just a little different, okay? So what I'm going to do is I'm going to copy this statement here, and I'm going to paste it right underneath as a comment. Now you can write this down on a notebook if you'd like, but I'm going to paste it here as a comment. Now all I'm going to do is I'm simply going to replace the n variable with its given value. So at this point we know that n is 4, right? So I'm just going to replace n with 4. This right here, 4 minus 1, we know that that is 3, okay? So here on the left side, that's pretty straightforward, right? 4 times, okay? And then here on the right side, this factorial call is supposed to return an int, okay? If we look up here, we see that int is a return type. So every time the factorial method is called, it must return an int, okay? So we expect an int to be returned from this. The problem is that we won't know the exact value of that int until we go down the rabbit hole and then we finally reach the base case, okay? So what I do is I then go one level below and I bring down the 4, okay? The 4 doesn't go anywhere, okay? All we're doing here is we are unwrapping this factorial call, okay? So we look at the input here, it's 3, and what we do is we go back up here and just follow the logic. Now this is different from the previous example where I pretty much just copy and pasted the whole logic underneath. You can do it that way if you want. This way is a little less messy, okay? So anyway, 3 is the new input, so we go here, it checks. If 3 is equal to 1, do this. That's not the case, so it goes down here. And all we're going to do is simply copy this statement, and we're going to paste it right there. Now, all this is doing is it's replacing this. Okay, let me see that one more time. We are replacing this with this. Okay, so we know that at this point n is 3, right? So we're going to replace n with 3. And then this right here, 3 minus 1 is 2. Okay, just like that. So now we go one level below. We carry down the 4. We carry down the 3. And then let's go ahead and unwrap this factorial call. So right here, the input is 2. So here it checks if 2 is equal to 1, do this. That, of course, is not the case. So it goes onto the next line. And we simply copy this statement and we paste it here. Okay. Again, we are replacing this with this that we just pasted. Okay. Okay, so now we plug in the numbers for n. We know that at this point n was 2. So we type in 2, and then right here we type in 2. So 2 minus 1 is 1, right? Now let's go ahead and unwrap this factorial call. So 1 is the input, so it checks here. If 1 is equal to 1, then return 1. Now 1 is equal to 1, so it is going to return 1. So we can replace this right here with 1. And we are left with 4 times 3 times 2 times 1. Now it's going to do the math from left to right because the computer does follow the order of operations. So if we do the math, it's going to do 4 times 3, which is 12, times 2, which is 24, times 1, which is still 24. You'll see up here in the main method, I'm calling the factorial method, okay? And I'm giving it the input of 4. And I'm wrapping the whole thing on a system.out.println so that we can see the answer on the console window. So I'm going to go ahead and click Run. And you'll see right here, it prints out 24. All right, so hopefully things make a little bit more sense now. If this was easier, feel free to do it this way. If not, you could always just do it the way I did it in the previous example, whatever works best for you. Stay tuned for the last example where we're going to go over a recursive method that deals with the Fibonacci sequence. All right, congratulations everyone for making it this far. In this example, in this final example, I should say, we will be looking at a recursive method that gives us the number at a given index for the Fibonacci sequence. So before we dive into the code, let's go ahead and just go over what the Fibonacci sequence is. So the Fibonacci sequence is a pattern that we see all over nature and biology, and it's really easy. All you have to do is just add the last two numbers, and you keep doing that for however long you want. So for example, let's say that we start with the number 0. So we would do 0 plus 1, which is 1. And then we would do 1 plus 1, which is 2. And then we would do 1 plus 2, which is 3. And then we would do 2 plus 3, which is 5. And then 3 plus 5, which is 8, and so on. And you can go on and on for as long as you want, okay? Now, it's super important to note that some people define the Fibonacci sequence as starting from 0. And some people define the Fibonacci sequence as starting from 1. Now, I've been taught that the Fibonacci sequence starts from 1, but I've seen in other math books and online that it can start from 0 as well. The only thing is that if you're starting from 0, you have to start counting from 0. So for example, if we are trying to find the fourth number in the sequence, and we are starting from 0, then we have to start counting from 0. So we would do 0, 1, 2, 3, 4. So here we get 3, right? But if we're starting from 1, then we have to start counting from 1. So again, if we're looking for the fourth number, we would do 1, 2, 3, 4. And so we would still get the same number, right? It's just a different way of getting to it. So the sequence that we're going to be using here will be this one. So we'll be starting the Fibonacci sequence from 1. Okay? All right, so for this fib method, it's going to take in an integer and it's going to return an integer. So let's pretend that we provide the number 4 as the input. With that, it's going to return the fourth number in the Fibonacci sequence. So if we go here through the flow, again, if the input is 4, n is going to be 4. So here it's going to check if 4 is less than or equal to 1, then return n. The reason it'll return n and not 0 or 1 or a specific number is because you'll see that once we draw out the tree and we get to the base cases, you'll see that the base cases will sometimes result in a 0 and sometimes in a 1. So that'll make a little bit more sense in about a minute or two once we start drawing the tree, okay? So because n is 4 at this point, we know that this is going to fail, and instead it's going to return this right here. Now you'll notice that it's calling itself twice, here and here. You'll also notice that the input is slightly different. Here there's a change of n minus 1, and here there's a change of n minus 2. And it's basically going to add the returned integers for each of those calls. So to better visualize and understand what this method does and how it does it, the best approach is to draw out a tree. Now, this is slightly different than the approach we took in the previous examples, but I think it is best for this example because here we have two recursive calls, and so things can get really messy very quickly. So with that, we're going to start at the very top with the first call to the fib method. Now we said we were going to use 4 as the input, right? So we're going to write fib 4 at the very top. So since 4 is going to be the input for this fib call, we're going to go here through the logic like we were earlier. We know that at this point n is 4, so this is going to fail and it's going to return this. So we want to write this right underneath fib 4. So write down fib n minus 1 plus fib n minus 2. And because n at this point is 4, we simply replace n with 4. So now it's going to say fib 4 minus 1, and that'll be fib 3. And then on the right side, you're going to do fib 4 minus 2, and that'll turn into fib 2. So now let's focus on the left side. Let's focus on fib 3. So with the fib 3 call, 3 is the new input. So we go through the flow, and n at this point is 3, so we know that this check is going to fail. And it's going to return this right here. So we do the same thing. We write this down underneath fib 3. Because n at this point is 3, we're going to replace n with 3. So now it's going to be fib 3 minus 1, which will turn into fib 2. And then this one here is going to be fib 3 minus 2, and that'll give you fib 1. Now if we focus on fib 2, here on the right side, for this new fib call, 2 is going to be the new input. So we go through the flow here. N is 2 at this point. So this is going to fail, and it's going to return this. So we go ahead and write that right underneath fib 2, just like we did with the other ones. So because n at this point is 2, we simply replace n with 2. So now it's going to be fib 2 minus 1, which will give you fib 1. And then we're going to do fib 2 minus 2, which will result in fib 0. So here on the left side, we have another fib to call. And we just did that here on the right side, so you can go ahead and just copy that and paste it over. So now we look at fib 1. 1 is going to be the new input, so here n is going to be 1, and it's going to check. If 1 is less than or equal to 1, then it returns n. So we finally reached the base case for this. So we can go ahead and circle this fib 1. Now we do fib 0. With fib 0, 0 is the new input, so n at this point is 0. And here it's going to check. If 0 is less than or equal to 1, which is true, right? It's going to go ahead and return n. It's going to return 0. So we've also reached the base case with fib 0. So you can go ahead and circle that. So because we know that fib 1 returns 1 and fib 0 returns 0, we know that we finally reached the base case for these fib calls. And you can go ahead and circle the fib 1 and the other fib 1 and the fib 0 on the line above. And all we have to do now is simply add all the numbers that are being returned by these fib calls. So we do 1 plus 0, which is 1, and then we go one line above here. So now it's 1 plus 1, that's 2, and then we add another 1, that's 3, and then we add 0, that's still 3, and 3 is our answer. And you'll see here in the main method, I'm calling the fib method with 4 as the input, and I wrapped everything in a system.out.println. So if I go ahead and run it, so you'll see that I get 3 as the answer. So hopefully you feel a little bit more confident working with recursion. Now keep in mind there is no one-size-fits-all solution for recursion. You sort of have to feel comfortable working with different recursive problems. Just keep in mind that you will need these three things in recursion. You need a base case, a recursive case, and some sort of change. All right, so that is all for this video. Thanks so much for watching, and I will see you next time. Thanks.